So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic energy changes. So guys, this video will be about endothermic and exothermic reaction. So in short, stay till the end of this video because this will be a very important one. And guys, already you know that at any point where you want to answer any question, you can always pause this video and try out the question to see if you can get the answer to the question. So let's start with the first question here. It says, the average amount of energy associated with making or breaking 1 mole of a particular bond in its gaseous state is called A. Entropy, B. Free energy, C. Bond energy, D. Enthalpy. So guys, the answer to this question is bond energy, and that's option C here. So let's quickly go ahead and check out the next question. Question number 2, it says, combustion is a chemical reaction which is always accompanied by A. Heat and power, B. Heat, C. Heat and light, D. Heat and energy. So guys, the answer to this question is option C here. That's heat and light. So we need to understand that combustion is always accompanied by heat and light. So most substances burn in air, and burning or combustion is a chemical reaction which is frequently accompanied by the production of light and heat. So that's it for that question. Let's consider the next question. Question number 3 here. So the question says, a reaction with a negative enthalpy change is A. Exothermic, B. Isothermic, C. Endothermic, D. Adiabatic. So guys, the answer to this question here is exothermic. A reaction that has a negative enthalpy change, that's a negative delta H, will be regarded as an exothermic reaction. So guys, that's the answer to this question, option A. So let's consider the next question. Question number 4 here. It says C2H4 in gas plus H2 in gas to yield C2H6 in gas with delta H as negative 137 kilojoules per mole. The reaction represented above is A. Spontaneous, B. In equilibrium, C. Endothermic, D. Exothermic. So guys, we've already established in the previous question that a reaction that has a negative delta H is exothermic. So guys, you don't really need to think about this one. Already, you know the answer to this question should be here, option D. And that's exothermic. So let's quickly check out the next question. Question number 5 here, it says, so we also have an equation of a reaction here. I'm not going to just read out the equation. You can see the equation here. So let's simply read out the question here. It says, calculate the enthalpy change in the reaction above. If the enthalpy of SO2 gas is negative 297 kilojoules per mole, and that of oxygen gas is 0 kilojoules per mole, and then that of SO3 gas is negative 395 kilojoules per mole. So guys, this is something we can both solve together. So let's just quickly zoom into our workspace and solve these out together. So let's go ahead and write the equation of the reaction here. We have 2SO2 here. That's 2SO2, then plus O2 to yield 2SO3. So given that delta H for SO2 is negative 297, so delta H for SO2 is negative 297, kilojoules per mole, and then that's for O is just 0, and then for SO3 it's negative 395. So this is all in kilojoules per mole. The change in enthalpy for the reaction will be the total change in enthalpy for the products minus that of the reactants. Okay, so over here, we're going to recall that the delta H for reaction will be given as the total delta H for the products minus the total delta H for the reactants. So now, having this, already we know the total H for the products, and that's going to be 2 times negative 395. So let's go to our calculator and check this out. 2 times, just going to use 395 here and then add negative to the answer. So this will give us a negative 790. So it means that delta H for the reaction is going to be a negative 7. Okay, this is equal to a negative 790 minus the delta H for the reactants here now. So we're also going to do negative 297 times 2. So that's negative 297. So negative 297 times 2, that's negative 594. So we have a negative 594 here. So with this, guys, we know that since we have negative here, that translates to a positive, right? So we're going to have this to be equal to negative 790 plus 594. So guys, let's solve this out together. Negative 790 plus 594, that would be a negative 196. So that's negative 196. So guys, viewing in right here, we have this answer to be option C here. So guys, that's the answer to this question. Option C here is the answer to this question. So that's it for that question. We're going to wipe all this and then we'll consider the next question, and that's question number 6 here. So guys, question number 6 says, when delta H is negative, a reaction is said to be A, exothermic, B, endothermic, C, reversible, D, ionic. So guys, the answer to this question is option A here, and that's exothermic. So let's consider the next question, question number 7 here. So guys, question number 7 says, which unit is commonly used to express the heat of combustion? A. Grams per liter. B. Kelvin. C. Meters per second. D. Joules per mole. So guys, the answer to this question is option D, and that's joules per mole. Joules per mole is often used to express the heat of combustion. So let's check out the next question, guys. Question number 8. It says the enthalpy of formation of an element in its standard state is A. Positive, B. Negative, C. 0, D. Depends on the element. So guys, the answer to this question is option C, and that's 0. The enthalpy of formation of an element in its standard state is actually 0. It's defined to be 0 actually. So this actually allows us to measure enthalpy change of reactions involving these elements. So that's it by that. So let's consider the next question. That's question number 9. It says the heat of reaction can be determined experimentally using a device called a thermometer, B. barometer, C. spectrometer, and D. calorimeter. So guys, calorimeter is the answer to this question. A calorimeter is a device that is used to measure the heat of reaction experimentally. So guys, that's option D here, and that's the answer to this question. So let's consider the question number 10 here. The question says, alright, here we have an equation of a reaction here. It's hydrogen gas reacting with iodine gas to form hydrogen iodide. So this will in gas form too. So from here, the delta H is positive. And then the question says, from the equation above, it can be inferred that bond breaking energies are A. equal to bond forming energies, B. equal and opposite to bond forming energies, C. less than bond forming energies, D. greater than bond forming energies. So guys, the answer to this question will be option D here. That's greater than bond forming energies. The enthalpy of this reaction is actually positive, and that means it is an endothermic reaction. So in this case, this will suggest that the bond breaking requires absorption of heat, and bond formation requires release of heat. So in this case, guys, the bond breaking energies will be greater than the bond forming energies. So that's the answer to this question, guys. Option D is the answer to this question. So this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So guys, we also want to use this medium to encourage you to join our YouTube channel community. Thank you once again for watching this video. See you next time.